The Common Sensor Platform is an effort across EarthScope and across all of our engineering disciplines in EarthScope to standardize our station designs as much as possible into kind of a core standard station design that is both modular and scalable and essentially flexible to the different types of stations that we set up around the world.
We have portable stations, permanent stations in radically different environments sometimes, and it's an opportunity for us to take stock of what we're currently operating, look at new technologies and new observations that we could be collecting, and look at how these might be optimized maybe within a narrower range of station designs in the future.
Yeah, and ultimately working out common test procedures, common recommendations for certain pieces of equipment, or at least common specifications to help the community. We want to also generate some commonalities between our two groups, maybe common suite of charge controllers, solar panels, distribution systems, and kind of take the best practices from both groups and mesh them together and learn from each other.
This Common Sensor Platform meeting and project is really valuable in the collaboration between multiple different subgroups of former UNAVCO and IRIS that are now one organization. So we're kind of seeing there are major differences in where we do our work, but there are commonalities in the way that we build our infrastructure and how we mount our solar panels, or how what types of batteries we use and that kind of thing. So GSN, which is the Global Seismic Network, they have some stations that are relatively close to an AC power grid. Their power consumption can be huge because they can just plug directly into AC power. We can't even remotely consider that in polar regions. I think of this as a very exploratory exercise in this phase of this project of where are we similar, where might we move forward with merged, not only designs, but merged engineering processes, merged documentation repositories, and that kind of thing.
So, sensors, we have seismometers that are in place below ground. We have geodetic receivers that are mounted on monuments above ground. We have magnetotelluric sensors, which are electric and magnetic field sensors that have their own requirements. We've had 10 so far, what are called station design reviews, where one or two presenters with some real knowledge about one of our networks or class of stations that we operate kind of take a template which is standardized and then put their own stamp on it.
So one thing that we've noticed is that most of these stations have a lot of very common types of subsystems. Every station needs power, for example. That's one subsystem. Every station has a sensor that's sensing something, whether it's a signal from space, a ground motion. Most of these stations are also pushing data from the station to a hub, a data hub somewhere. Not all of them, but most of them are, so there's some element of telemetry as well.
But they've all evolved in parallel by different groups, and so this is an opportunity for us to kind of break down those silos and talk about maybe common lessons that we've learned along the way, or one group might have learned a lesson that could be discovered by another group and leveraged for future station work.
But I think this has given us time to think about maybe common sensor, a more complicated, sensor that can do more things in different applications. So maybe a strain meter that can be a broadband seismometer and a tilt meter and a rotation meter. That's one of the examples. And there's some of these that are currently being developed right now that are really exciting. And I think this gives us some focus on how to evaluate these new instruments and potentially pass on our needs to the manufacturer who's developing these instruments and kind of get a bespoke strain meter for EarthScope that can also be used by the wider community.
And one of the directions that we've seen in the technological market over the last decade is that there's lower power instruments available, there's better, more versatile options for doing emplacements. The downstream effect of that is people might need to spend less time on site. Less time on site means maybe your budget for field work is not as large. Maybe you have more flexibility in how you're able to go out and deploy your instruments. But it's almost certain that across this portfolio of stations that there may be some real efficiencies that are realized long term. And that has real implications for just making the science easier to do.
If you talk about solar panels, for example, right now, if we were to send you a geodetic system to install in Antarctica, for example, and a seismic system, the solar panels sizes are different, the mounts are different, they use different sizes of bolts, you need 2 different types of wrenches, multiple actually, you know? So I think there's just like an ease of we send a PI into the field if they want, you know, a seismic system or a geodetic system. They're hopefully out of this project will be a little bit more streamlined in terms of like what you are doing in the field.
When you go out and get that data and it's not as taxing a process, you have more time to actually analyze it and do the actual, you know, interpretations and science work for it.